I made a sandwich of the sapphire, and then I put liquid gallium on it, and then I put a chip of silicon on top of that, and I left it there for over 28 hours, I think, to check to see, because if you remember, the gallium was acting a bit weird, and it was staying liquid for longer than it should have. If I leave the gallium to sit at room temperature, which is much below its melting temperature, if I leave it there for over a day, it should solidify, right? So I come back Saturday evening, and I pick up the gallium sandwich, and I poke the piece of silicon, and it moves. And I look underneath it, and the gallium is still liquid. And at that point, I just say, what is going on? Because I have no idea. I talked with my friend, Andrea Bollinger. She's a material science major at University of Florida, and she said, I'm not sure what's going on, but, maybe metals can dissolve into each other fairly easily, so maybe silicon is dissolving into the gallium and changing its properties. So I talked to Professor Smith, and he said he'd talked to one of his friends and tried to figure this out, because at the moment we have no idea, which is kind of cool from the this is an interesting mystery standpoint, and then also kind of this is really weird. He thought, okay, maybe if something is dissolving in from the silicon somehow, maybe something else dissolved in from the metal spatula. I thought, okay, instead of poking it with the spatula this time, I'm just going to try scraping it off with the piece of silicon and see if that does the same thing. So I did that, and for a few seconds, like maybe up to 20 or 30 seconds, the gallium stayed mostly liquid in a blob. It started to turn into kind of sludge. Basically, the upshot of this is that gallium will not work for my task of gluing my real silicon sample to the sapphire inside the vacuum chamber, because it stays liquid and doesn't apparently attach to silicon and various problems like that.